In this episode, we look at network, remote access, and endpoint threat sources, which are some of the most common paths attackers use to reach real systems and real data. These areas matter because they sit directly between people, devices, applications, and the internal environment. A network device may move traffic between systems. A remote access tool may let someone work from another location. An endpoint may hold credentials, files, browser sessions, and access to business applications. Attackers understand this, so they look for weak infrastructure devices, exposed remote access services, poorly protected mobile devices, vulnerable servers, trusted devices, and built-in administrative tools that can be misused. The main idea is not that these technologies are bad. The main idea is that anything designed to connect, manage, or access systems can become dangerous when it is misconfigured, unpatched, stolen, overtrusted, or used by someone with malicious intent. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. Infrastructure devices are the equipment and systems that help a network function. This can include routers, switches, firewalls, wireless access points, load balancers, gateways, and other devices that move, filter, or shape traffic. These devices are attractive targets because they often sit in powerful positions. A compromised network device may let an attacker observe traffic, redirect traffic, bypass controls, or create a hidden path back into the environment. Infrastructure devices can also be overlooked because people may think more about laptops and servers than the devices that connect them. If a router or firewall is running old software, using weak management access, or exposed to the wrong networks, it can become a serious threat source. You should think of infrastructure as part of the protected environment, not as invisible plumbing. If it controls movement, visibility, or access, then it needs security attention. Virtualized devices add another layer to this picture. A virtualized device is not a separate physical box in the traditional sense. It is a software-based system that acts like a server, firewall, router, desktop, or appliance inside a virtual environment. Virtualization makes modern computing flexible because many systems can run on shared physical hardware. That flexibility is useful, but it also creates security concerns. A virtual server can be copied, moved, connected, or exposed quickly. A virtual network device may control traffic between important systems without looking like a physical appliance in a rack. If attackers compromise the management layer that controls virtual systems, the impact can be wide. They may create new systems, change network paths, take snapshots, or access stored data. For you, the important lesson is that virtual does not mean imaginary. A virtualized device can support real business functions and create real security risk. Session keys are another important threat source because they help protect or maintain secure communication. A session key is a temporary cryptographic key used during a communication session to help keep data private and trustworthy. You do not need to become a cryptography expert here. What matters is that session keys are part of how systems protect communication after a secure connection is established. If an attacker can steal, predict, misuse, or otherwise compromise session-related secrets, they may be able to read information, impersonate a party, or interfere with secure communication. Strong systems protect session keys carefully and avoid reusing them in unsafe ways. Weak implementations, compromised endpoints, or poor handling of secrets can change the risk. Session keys remind you that security is not only about passwords. Temporary trust material can be just as valuable to an attacker if it helps them act inside a protected conversation. Remote desktop access is a common target because it is designed to let someone control a system from another location. That can be very useful for support, administration, and remote work. It can also be dangerous if exposed too broadly or protected poorly. An attacker who gains remote desktop access may see the screen, use applications, browse files, run tools, and act as though they are sitting at the machine. Weak passwords, stolen credentials, missing multi-factor authentication, MFA, exposed services, and unpatched systems all increase the danger. Remote access should be treated like a controlled doorway into the environment. If that doorway is visible to the internet, attackers may try to guess passwords, test stolen credentials, or exploit weaknesses. Even when remote desktop is only available internally, it can become useful to an attacker who has already gained a foothold and wants to move deeper. Virtual network computing, VNC, is another remote access technology that allows screen sharing and remote control. Like remote desktop, it can be legitimate and helpful when used carefully. The risk appears when it is exposed, weakly authenticated, unencrypted, misconfigured, or forgotten after temporary use. A VNC service left open can give an attacker a direct view into a system. Even if the attacker cannot immediately control everything, visibility itself can be valuable. They might see applications, usernames, documents, system names, or internal processes. Some environments use remote access tools for maintenance, operations, or support, and those tools may remain in place for years. Attackers often look for these services because they can provide interactive control. The lesson is not to memorize one remote access product as bad. The lesson is to recognize that any tool allowing remote control needs strong authentication, limited exposure, logging, and ownership. Virtual private network, VPN, connections are also important because they are designed to create protected access from one network to another. A VPN can help remote users reach internal resources securely, but it can become a major target because it sits at the edge of trust. If attackers steal VPN credentials, exploit a VPN device, or trick users into approving access, they may gain a path into the organization. VPN devices and services need timely updates, strong authentication, careful configuration, and monitoring. A common mistake is treating the VPN as the only barrier needed. Once someone connects, they should not automatically have broad access to everything. Strong security limits what connected users can reach based on role, device health, location, and need. The VPN should be a guarded entrance, not a master key to the entire building. Mobile devices and tablets create their own threat sources because they move between networks, locations, and personal spaces. A phone or tablet may hold email, cloud applications, authentication prompts, save files, messaging apps, and browser sessions. It may connect through home Wi-Fi, public networks, cellular networks, Bluetooth, and workplace systems. That mobility is useful, but it also makes control harder. A lost phone can expose data if it is not locked or encrypted. A compromised mobile device may receive authentication prompts or messages that help an attacker. A user may scan a quick response code, QR code, open a link from a text message, or approve a request while distracted. Mobile devices also blur personal and work activity, especially when employees use the same device for both. Security teams respond with device management, strong screen locks, encryption, application controls, and the ability to remove business data when needed. Servers are major targets because they often hold data, run applications, provide identity services, store files, or support business processes. A compromised server may give attackers access to many users or systems at once. Public-facing servers are especially exposed because they are reachable from outside the organization. Internal servers matter too because they may hold sensitive data or trusted access. Attackers may target servers through unpatched software, weak credentials, misconfigured services, stolen administrator access, or vulnerable applications. Once inside, they may search for databases, configuration files, credentials, backups, or connections to other systems. Servers can also be used as launching points for further activity. Because they are expected to run continuously and communicate with many systems, malicious activity can sometimes blend into normal traffic. Good server security depends on patching, hardening, logging, access control, segmentation, and clear ownership of what each server does. Trusted devices can create a special kind of risk because other systems may treat them as safe by default. A trusted device might be a managed laptop, an administrator workstation, a server, a security tool, or a device enrolled in a trusted access program. Trust can be useful because it lets organizations apply policies based on device status, ownership, configuration, or location. The danger appears when trust becomes too broad or too permanent. If an attacker compromises a trusted device, they may inherit some of that device's credibility. Security systems may allow access because the request appears to come from a known device. This is why device trust should be checked and refreshed, not assumed forever. A device can be trusted yesterday and risky today. Health checks, updates, endpoint protection, certificates, and monitoring all help make device trust more reliable, but trust still needs limits. Built-in tools are another major concern because attackers often use tools already present in the environment. This is sometimes called living off the land. Instead of bringing obvious malware, an attacker may use normal administrative tools, scripting environments, remote management features, file transfer utilities, or system commands that defenders expect to see in legitimate work. This approach can help attackers avoid detection because the tool itself is not suspicious. The suspicious part is the behavior. A tool used by an administrator during a maintenance window may be normal. The same tool used by a regular user account at an unusual time to access many systems may be a warning sign. Living off the land attacks remind you that security monitoring cannot rely only on blocking known bad files. It also has to understand context, roles, timing, destinations, and patterns of use. Endpoint threats are especially important because endpoints are where people interact with systems directly. A laptop or desktop may contain browser sessions, cached credentials, documents, collaboration tools, and access to internal or cloud resources. Attackers may target endpoints through phishing, malicious attachments, browser attacks, infected downloads, removable media, or stolen credentials. Once an endpoint is compromised, the attacker may try to steal information, capture passwords, install persistence, move to other systems, or use the device as a base for further activity. Endpoint security often includes anti-malware tools, behavior monitoring, patching, disk encryption, application control, and least privilege. Least privilege means the user or process only has the access needed for the job. If every user has broad local administrator rights, one endpoint compromise can become much more damaging. Reducing endpoint privilege helps shrink the blast radius when something goes wrong. These threat sources often connect to one another. An attacker may start by compromising an endpoint through a message-based attack. From there, they may steal credentials, connect through a VPN, use remote desktop to reach a server, and then use built-in tools to move quietly. Another attacker may target an infrastructure device first, then observe traffic or create a hidden path into the environment. A lost mobile device may expose email access, which leads to password resets or social engineering. A trusted device may become a stepping stone because other systems allow it more access than an unknown device. This connected nature is why security teams think in attack paths. One weakness may not seem catastrophic alone, but it can become serious when it helps an attacker reach the next step. Protecting each source matters because attackers rarely need every door to be open. They only need one path that works. Defending these areas requires layered controls because no single protection solves every problem. Infrastructure devices need updates, secure management access, strong configuration, and monitoring. Remote access needs MFA, limited exposure, logging, and access restrictions. VPN connections need careful segmentation and should not provide unnecessary reach. Mobile devices and tablets need encryption, screen locks, management, and safe application practices. Servers need patching, hardening, backups, monitoring, and controlled administrator access. Trusted devices need ongoing health checks and should not receive unlimited trust. Built-in tools need monitoring based on behavior, not just tool names. Endpoints need protection, least privilege, and user awareness. The goal is to make each step harder for the attacker. Even if one layer fails, another layer should slow, detect, or limit the attack before it becomes a major incident. As you continue with Security Plus version 8 and SY0801, remember that network, remote access, and endpoint threat sources are dangerous because they are connected to everyday work. Infrastructure devices move traffic. Virtualized devices support real services. Session keys protect active communication. Remote desktop, VNC, and VPN connections create access paths. Mobile devices, tablets, servers, and trusted devices hold or reach valuable resources. Built-in tools can be used for legitimate administration or malicious activity. Attackers study all of these areas because they offer ways to enter, move, hide, and act. Your job as a defender is to see those paths before the attacker does. When you understand how normal connectivity becomes an attack path, you can think more clearly about exposure, trust, monitoring, and control.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.